So now we want to look at factorization from the angle of binary factorization with two perfect squares or no perfect square. So I'm going to consider these two questions, this one and this one. So let me start with this one. We have example number 2, where we have 36 minus 9a squared. You can see that 36 has a perfect square, which is 6, and 9 has a perfect square, which is 3. So this is a good example of binary factorization with two perfect square. Yes, so what are we going to do? In this case of binary factorization with two perfect square, you are going to alter the negative sign between the two. Unlike binary factorization with just one perfect square or no perfect square, you are not going to alter this. You leave it like that. But in this case, you are going to alter this. So this one becomes, this minus becomes minus times plus. So that's the difference when we are dealing with binary factorization with two perfect square. So now let's work it out. We have 36 as 36 becomes 6 times 6, and the minus becomes minus times plus. Minus times plus. And the 9 becomes 3. This is the 9, becomes the minus becomes this. 9 becomes 3 times 3, and the a square becomes a times a. So we have to rule it out like this. This will be our first bracket, and this will be the second bracket. So let's put it out. Right, first bracket, and this second bracket. So let's look at it. Then we'll put it here. 6 minus 3a. That is this one, the first bracket, like this. Now it's vertical, now it's horizontal. And the second bracket is this. 6 plus 3a. And this is our answer for this question given. So if we do a distributive concept from here, we are going to get this. Now let's check. Distributive concept. 6 minus 3a, close bracket, 6 plus 3a. Now let's do the distributive concept. This multiplied by this, and like this. Then for this, and this distributive concept. And let's see what comes out from it. So we have it here. Good. So we have it here. So let's put it somewhere here. So we have it as what? 36, this times this, 36, then this times this, plus 18a, then this times this, minus 18a, then this times this, minus 9a squared. So now you are holding, this is bar concept. From year to year we call it bar concept. You are holding 18a, you have 18a, and you are holding 18a. So when you sort it out, it means you are not holding anything. So we are left with 36 minus 9a squared. Let's check it out. 36 minus 9 squared. That's it. Thank you, guys. Alright, now let's look at this. The question number 3, which is example 3. We have 2 pi rh minus pi r. So now, this is binary factorization with no perfect square. With no perfect square. So in this case, the negative sign here must not be altered. It must not be altered. It must not be altered. So it must not be altered. Do you understand? Yes. So what we are going to do is that we use vertical concept. Vertical concept. Let's split it out. We have 2 times pi times r times h minus pi times r. Now our vertical concept is that we have pi here and we have pi here. We have to cancel this out. We'll bring it out. Then we have r here and we have r here. We have to cancel this out. we bring it out. So from here to here, and from here to here, nothing is common. So from we have here this and this. We open bracket, we have the 2 here and the h here. And minus all this becomes 1. But there's nothing, so we can't leave it as empty. Put 1. So 1. And this is our answer. So if you do a distributive concept, if you multiply this with this and this, you get this back. And that is it. So thank you guys. So I will leave you with this. Go and try question number 1 and tell me which of the concepts you can use. So the assignment you are going to do is that you go home and try the question number 1 and tell me, are you going to use the binary, any concept that you can use that will give you the answer. You are going to get that along the way as you are trying to solve. So go and try question number 1, and when next we meet, tell me what you can deduce from it. Thank you. It's a peace. Thank you. Bye. Next time we meet.